Today we are going to hit section 5.2, which is verifying identities. All the skills that are going to be addressed in today's lesson, we've covered somewhere else in chapter 5. We're just using them for a slightly different purpose. Okay, verifying an identity is kind of like a proof from geometry, except the trig version of it. So for our first identity, we want to show that tangent to the fourth is the same thing as tangent squared, secant squared, minus tangent squared. Now, the goal here is to show that the left-hand side is the same as the right-hand side. Okay, we can work on the right to make it look like the left. We can work on the left to make it look like the right. Normally what you do is you pick the more complicated side and try to simplify it to the less complicated side. Okay, what you're not allowed to do is you can't treat this as if it's an equation. Meaning you can't move terms from the right over to the left. You can't move terms from the left to the right. You can't multiply the whole thing through by something. You can't divide the whole thing through by something. You're not allowed to cross-multiply it as two fractions. Those are all things that are specific to equation-solving strategies where you're trying to find what makes what the variable needs to be in order to make the equation true. Here, we're showing that this is the same as that. So it's a slightly different set of rules. So whatever we do is to one side and one side only. So we can't take that negative tangent x squared, for example, and move it over to the right. Whatever we do is going to be just to this. We're going to work on the more complicated side and make it look like the simpler side. Now, the whole idea of this is to be showing all the steps. Now, perhaps you are good enough with mental math to be able to visualize that the right-hand side is the same as the left-hand side. Okay? But you're not being graded on how well you can visualize something in your head. Okay? There are plenty of things we've done in Chapter 5 where you're rewarded for your mental math skills. Here, this is not one of them. The showing the work is what you're being assessed on. All right, so all that being said, what are some strategies we could look for? Well, for this one here, the thing that'll work out pretty well is to notice tangent squared is common to both pieces or both terms on the right-hand side. So I'm going to factor that out. That's going to leave secant squared x minus 1. Okay, now that we're here, the next thing that you want to take note of is it appears as though we have some version of one of our Pythagorean identities. We know that 1 plus tangent squared is equal to secant squared. So secant squared minus 1 is tangent squared. Now we know tangent squared times tangent squared. That's tangent to the fourth. And now we've made the right-hand side look like the left-hand side. So we've successfully verified that identity. This here is not actually part of our final answer. That was just scrap work we did in order to realize what one of the next steps were. Next one we're going to do we want to verify this identity. Typically what you're going to do is try to make the left-hand side look like, or the more complicated side look like the more simplified side. In this case, we're going to make the left-hand side look like the right-hand side. Well, one thing that may jump out at you, because we just did it, we know secant squared minus 1 is tangent squared. So let's make that our first move here and see how that plays out. One of the things that we've done in this chapter is, in order to get expressions simplified or written differently sometimes, one thing to consider is, what if you change everything into sines and cosines? So let's try that here. cotangent, sine over cosine. Secant is 1 over cosine. So we just have to add in the exponents of the 2. And now, that cancels with that. And we have successfully verified that identity. Okay, keep in mind, again, emphasizing the work is your answer. Don't circle that like you're done and this is your final answer. The entire process of showing that this is equal to that is your final answer. All right, very often, there are multiple ways in order to verify any given identity. Sometimes there are methods that are clearly shorter than others. Sometimes one method is not necessarily better than another, simply a different way to get to the same end result. All right, what I'm going to do is verify this a second time, but use a strategy that I'm not sure we've addressed really in this class. If we did, it was kind of in passing. It wasn't anything we emphasized. If you have multiple terms on the top of a fraction and a single term on the bottom, it's fair game to divide that into everything that's above it. So in other words, we can split this up into 2 separate fractions. This particular method, you're going to use quite a bit in calculus next year. There are lots of problems in calculus where it's easier to deal with smaller, simpler fractions than bigger, more complicated ones. And that's simply splitting it up using this is a nice, clean method that works out pretty well very often. Okay, well, secant squared over secant squared is 1. 1 over secant squared is cosine squared. And this guy we recognize 1 minus cosine squared is the same as sine squared. And that is an alternative way to verify that same identity. Neither one of these is better nor worse than the other. Roughly the same number of steps, just different ways to get the same job done. All right, next example, same set of instructions we have for all of our problems today. We want to verify this identity. A general thing you want to look for is try to simplify the side that appears to be more complicated to make it look like the simpler side. Well, for this one here, each side is 2 terms. Trig function, trig function, trig function, trig function. Or 2 trig functions at each side. Technically, that's 1 term, but I digress. Back to this. So it may not necessarily be clear, well, which side is more complicated. One strategy to try is if you notice one side has multiple terms, and this side is connected by multiplication, that's technically 1 single term, although I misused that phrase a moment ago. Try adding these together through some type of addition, fraction addition or subtraction, and see if you can make that look like this. So that being said, I'm going to rewrite tangent as sine over cosine. I'm going to rewrite cotangent as cosine over sine. The common denominator is going to be sine cosine. So from there to there, we got to multiply by sine. There to there, got to multiply by cosine. Making a single fraction out of that. Sine squared plus cosine squared is 1. And then 1 over sine is the same as cosecant. 1 over cosine is the same as secant. I'm just going to flip that order so it matches as it appears over here. Okay, the bottom line for any verification should always be something equal to itself. Now, being there are different paths in order to show that the left-hand side is the same as the right-hand side, not everybody's bottom line is the same. Depending on the path you take, it may be a different bottom line. Like, for example, with this one here, rather than flipping the sine cosine up to make it secant cosecant, could have taken these guys and flipped them to the bottom of the fraction, and then made that my final answer right here. 1 is over sine cosine. All right, next example, verifying this identity. Now, it's a single fraction on the left, it's a single fraction on the right. So there's not necessarily a clear one side is more complicated than the other. Well, if this one here is sines, and that's cotangent cosecant, well, this is a simpler set of trig functions. So using that, I'm going to look for the more complicated side to work on first. This definitely is the one that we're going to want to concentrate on. Now, as a reminder, you can't cross-multiply. Cross-multiplying is a feature that is allowed to be, or a strategy that can be used in solving equations, not verifying identities. Whatever we do needs to be one side and one side only. We can't do a step that incorporates both sides at the same time. Okay, that being said, one of the more efficient ways in order to verify this is to kind of do a reverse Pythagorean substitution. What I'm going to do, 1 plus cotangent squared equal to cosecant squared. I am going to bring this over here. Oops, sorry, I didn't realize that went off the screen here. Very often we've used replacing cosecant squared x, or cosecant squared, whatever the variable is, minus 1, with cotangent squared. It's not very often we replace cotangent squared with this. That's going to be the trick in order to getting this done here. So it's kind of the reverse of the substitution we've used more often in Chapter 5. So what I'm going to do is make that substitution. So that's cosecant squared theta minus 1 over 1 minus cosecant theta. That's a difference of 2 squares. I copied this wrong. That's a plus. I'm sorry. Plus. Okay, factoring that as a difference of 2 squares gets us to there. Cosecant plus 1, 1 plus cosecant, well, they're the same. They can cancel. So on the left-hand side, we're left with cosecant of theta minus 1. Now I'm going to stop there because that's relatively simple. To try to get that to look like this turns out to be a little bit more work than we would prefer to do here. It's much cleaner to, okay, let's leave this alone and let's do some stuff over here on the right and see if we can get that to look like this. So I'm going to use that strategy that we did a problem or two ago. Multiple terms on top and a single term on the bottom. One over sine is cosecant minus 1, cosecant minus 1. So here's an example where we worked on both sides, but we did them independently of each other. The stuff that we did on the left side had nothing to do with what we did on the right. The stuff we did on the right had nothing to do with what we did on the left. So sometimes, referring back to our first couple of examples, you're going to make the right-hand side look like the left-hand side. Sometimes you're going to make the left-hand side look like the right-hand side. Sometimes you work on the two sides independently to get them to be something the same that they're equal to. Okay. Another emphasis, this is not part of our answer. That was just scrap work we used in order to get this done on the left-hand side. Don't circle the bottom like that's the final answer. The final answer is the process that showed that those two expressions up top were the same. Excuse me. All right, next example, we want to show that this is the same as that. One path we could take is to recognize that we have Pythagorean identities in both of those. So for this one here, we know that 1 plus tangent squared is equal to secant squared. So secant squared minus 1 is going to be tangent squared. So we can make that substitution, that for that. We know also as scrap work over on each side, sine squared plus cosine squared is equal to 1. So if we take that plus 1 and bring it over here, take that, bring it over there, we get negative cosine squared. And I'm going to use my strategy of converting the sines and cosines. Cancels with that. All right, another path that we could have taken with this is we could have FOILed this out. That's always something to consider. So let me just do that underneath here. As possible path number 2, what if we FOILed this out on the left-hand side? That would be secant squared sine squared minus secant squared minus sine squared plus 1 equals negative sine squared. All right, next thing is, let's see if we can simplify some stuff up here. What do we got going on here? Secant squared is 1 over cosine squared. I'm going to leave that secant squared alone in a minute, for now. Minus sine squared plus 1. Okay, that is going to be the same as tangent squared. And then the trick to making this one work is we're going to take that tangent squared plus 1 and replace it with secant squared. And then they cancel. Negative sine squared equals negative sine squared. Okay, so this one, or this set of steps here, you have to be a little bit more creative. Because we converted this into sines and cosines, but that we did not. And usually when we've used this type of strategy before in the past, it would be everything would be converted into all sines and cosines. If we leave that, if we convert that into 1 over cosine squared, it starts to get a little bit messier. You'll eventually get there, but it's not a pleasant path. So this one up top, that solution is a little bit more cleaner. You don't necessarily have to be thinking outside the box. This one you have to get a little bit more creative in order to get the job done with that. All right, we'll do one more example for today, and I think that should be sufficient for what we want to accomplish. What number do we leave off with? So this will be number 6. All right, so the left-hand side, we have 2 separate terms. Right-hand side, we have a single fraction. So this one is kind of screaming that you probably want to put these in fraction form and add them together and see what happens. So secant is 1 over cosine. Tangent is sine over cosine. Which gives us 1 plus sine of x over cosine of x. That's a pretty simple fraction. There's not a whole lot we can do with that. You could split it up into 2 separate fractions. We've used that strategy, but that would end up making a full circle. That would take us back where we started from. Splitting this up into 2 separate fractions is not allowed. It's got to be multiple terms on top and a single term on the bottom. So we're going to do something here that I don't think that we've seen before as a strategy. This will be something new to section 5.2 that we haven't used in the rest of chapter 5. What we're going to do is we're going to multiply the top and bottom of that fraction on the right by the conjugate of the bottom. It's a legal move because of the fact that we are multiplying the top and bottom by the same quantity. So the top will be cosine plus cosine sine. The bottom will be 1 minus sine squared. Well, we know 1 minus sine squared is cosine squared. And that's the advantage of doing that conjugate thing. Is very often you end up getting some version of one of your Pythagorean identities. It's not guaranteed to work, but it works enough where it's a strategy to consider. Now what I'm going to do is I'll split this up into 2 separate fractions. And I'm thinking it probably would have been cleaner for me if I didn't multiply the top out. I think I added an extra step I didn't need to add to this. But it's okay. It still gets the job done. So this will be 1 over cosine of x plus sine x over cosine of x. And now we can see we're real close to that. So I'm going to revisit the left-hand side, and I'll split that up into 2 separate fractions. Oh, look at that. Actually, we can just go right to there. That was an extra step we didn't even need to do. 1 plus cosine of x plus sine of x over cosine of x. So I made this one a little bit more complicated than it needed to be. This one could have been done a little bit cleaner. I didn't need to do that step to this. I could have just left it like this. And the right-hand side probably would have been 1 step quicker if I didn't multiply that out. So this wasn't the most efficient way to get there. Kind of good that I did this in terms of to talk about it. If this were a quiz or test question, you don't have to verify the identity in the most efficient form possible. as long as you're using valid algebra, valid trig, you're showing all your steps, you're treating it as a verifying an identity as opposed to solving an equation. If there are a couple extra things you did in there that aren't necessary to get the job done, you're still going to get full credit. You're not going to get graded on the beauty of your verification. Just does it work or does it not? All right. I think that's a pretty good overview of what we need to know from Section 5.2. We will stop with this example.